In the previous video we have completed property 1 to 4. Now in this video we will continue the next property. Coming to the property 5. Property 5 says that if sum of all elements of a row or a column of the determinant are expressed as a sum of two or more terms, then we can just split that determinant. How we will do? Suppose we have this determinant. In this determinant, in row 1 we have sum of two terms. We have a1 plus x, b1 plus y and c1 plus z. So how can we split it? The remaining two rows will be unchanged. On the first row it will be a1, b1, c1. Then in the second determinant it will be x, y and z. Okay. So we'll just see one observation based on it. Suppose we have this determinant, then outside we have sigma. We know that this sigma can go inside in any row and any column. We will take that row or column in which we have the variable. So this sigma is for r equal to 1 to 1. So in whichever row or column we have the r function of r, in that we will take it. So this sigma we will take it column 1. So my column 1 will be sigma r equal to 1 f of r, and likewise the remaining two terms. The other two remaining columns will be unchanged. Property 6 is value of the determinant is not altered by adding or subtracting the multiples of any row or column in other row or column. It means suppose we have this determinant delta 1, and in delta 2 what I am doing? a1 plus k times a3. It means here what I am doing? I am doing r1, and in r1 we are doing the change. r1 I am changing as r1 plus k times of r3. So if we see, each element we are changing, b1 plus k times b3, c1 plus k times c3. So here delta 1 and delta 2, the value will be same only, even though we have changed the row 1 in the delta 2. Okay, then the note remark on this property: while applying this property, at least one row or column must remain unchanged. It means can't change all the row columns simultaneously. In that condition the property won't hold. Okay, we'll just solve one PYQ, that is 2023 PYQ. So what is given? We have given that dk equals to this determinant, and then sigma k equal to 1 to n, sigma k equal to 1 to n, dk equals to 96. Then we have to comment on n. Okay, so what do we know? We have sigma dk. So can I say from here sigma k equal to 1 to n dk? It will be now tell me one thing, sigma we can take any row in any column, but in which we have k, in that we will take. So I'll say in the row 1 I'll take it. So if we will take in the row 1, it will be sigma 1, k will be 1 to 1, then sigma 2k, k will be 1 to 1, and sigma k equal to 1 to 1 minus sigma 1, and the remaining row will be unchanged. It will be the same only, n square plus n, remaining two will be same only. Okay, now from here what can we say? We can say that sigma 1 where k is 1 to 1, it will be n, like 1 plus 1 plus 1, how many times? N times. Okay, sigma k, it will be n plus 1 by 2, 2 and 2 gets cancelled, so n plus 1, so I'll say n square plus n. Here it will be again same, n plus 1 by 2, 2 gets cancelled, so n plus 1 minus n. So basically we'll get here n square, since it will be n square plus n minus n, so we'll get n square. Remaining two rows will be same only. Okay, now we have to find this determinant. What do we know? That if the determinant, either I can just open this determinant, but this determinant the entries are like n square, so rather than expanding it directly we'll go by the properties. Okay, just check out the row 1 and row 3. Can I say row 1 and row 3, two elements are same only? So if I subtract these two, then we'll get the zeros, and if we are getting the zeros in the determinant, that is the best thing, since while calculation the terms will be 0. So what I am doing, I am just applying the operation in row 1. Row 1 will be row 1 minus row 3. So we are doing in row 1, so row 2 and row 3 will be same. So row 2 and row 3 I am writing first, that will be same only. Okay, now writing the row 1. What is the row 1? Row 1 is row 1 minus row 3. So n minus n, 0. N square plus n, this will be 0. And here what we will get? Minus n minus 2. Now just expand it. So if we expand it, what will I do? I'll expand it through the row 1, since in row 1 we have 2 zeros. So if we expand through row 1, what we will get? We will get minus n plus 2 into this will go, it will be n into n cube plus n square minus n cube minus n square minus 2n. So from here n cube n square gets cancelled. Basically we'll get, so what we'll get? We'll get that sigma k equal to 1 dk equal to minus n plus 2 into minus 2n. So it will become, that is plus 2n into n plus 2. Now it is given that it is equal to 96. Okay, so how to solve it further? So from here we'll say n plus 2 equal to 48. So from here n square plus 2n minus 48 equal to 0. From here we'll say n plus 8 into n minus 6 equal to 0. Now n cannot be minus 8, so from here n will be 6. Okay, thank you.